let's get into it. I was asked to speak for perhaps 40 minutes and then have questions. I'm actually going to do it a different way. I'm going to speak in 10 to 15 minute bites, a series of sections, and I will pause at the end of each section and encourage some questions and discussion. And if anybody wants to shout out as I go along, that's fine. It's just remember I've got the microphone and therefore I've got a louder voice than you. Okay. You often hear it said there are two sides to the global warming or climate change problem. Who says that? When you think about it, you hear that from the media. And it suits the media because they present everything in those terms. They're about head-butting arguments. They always want, on the one hand, on the other. And they will tend to either take sides or imply that one of the sides of the argument they're putting is actually the right one, and the other one is what they call balancing up the equation, as it were. So they'll do an article on climate change and they'll ring me up and they'll have 2 paragraphs in the paper and there'll be 25 lines from somebody who's saying climate change is a hugely alarming thing, and then there'll be 1 line from me, which is the obligatory balance. So it is largely the media that like to present it that way. If you talk to a scientist, they will scoff at the idea there are 2 sides to climate change. Why? Because there's as many sides to the climate change issue, which is extremely complex, as there are qualified scientists studying it. And it's a gross oversimplification to say there's just 2 sides to the question. I prefer to look at it in a different way. I prefer to say there are 3 realities of climate change. The first reality is science reality. That's what scientists, with or without white coats, in the lab or in the field, do. They collect facts, they do experiments, they try to fit mathematical relationships to the results they observe, and they interpret them in a rational, logical way. That's the science reality of climate change. There's a second reality, which actually is a lot more in the media than the science reality. And that second reality is what I call virtual reality. And it's very like the games boxes that you have on your computers. It's about scientists with very powerful games boxes playing with computer models of climate change. Now, I don't use that word playing in order to put these people down. They're amongst the most intelligent, clever, technically trained people on the planet. And the climate models they construct, which have millions of lines of code in them, computer code, and which no one person understands any one of the models. There's about 20 of them in major labs around the world, and our CSIRO has one. No one person in the lab understands the model. The model is split up into modules, and different scientists are in charge of different modules. They are so complicated, these models, it's amazing that they can get them to run stably for long enough to actually produce some useful output. But what you need to understand is they are models. They are about imaginary climate futures. They're not about actual climate futures, and I'll come back to that point. So that's the second reality. The third reality is what, objectively as a scientist, I should call the socio-political reality. I tend at this point to block my copybook and call it the socio-political pathology. We live in a social society, and therefore you can't do science, you can't do computer modelling in abstract. You have to deal with the fact you're living in a society which rightly has views about environmental protection and rightly worries about climate change. So that's the third reality of climate change. It's got nothing to do with science. It's driven by political fashion, which is driven by getting your vote and mine. And it's a very powerful driving force that you must be aware of, and it's quite distinct from the science reality or the virtual reality. Okay, you often hear it said, the science is settled. There is a consensus. Several things to say about that, but the first is the consensus has nothing whatsoever to do with science. You've never heard a scientist say there's a consensus the sun's going to come up tomorrow morning. Scientists will tell you the sun is going to come up tomorrow morning and give you very good reasons why, including mathematical relationships. So as soon as you hear somebody in a science context saying there is a consensus that, that immediately tells you that the answer is unknown. And what you're really getting is the opinion. And it might be a very well-based, sound opinion from very good scientists, but it's an opinion. Science is settled. Well, sometimes I give a talk where I spend a whole 40 minutes destroying that particular assertion. But tonight I'm going to take the other tack. I'm going to say, yes, in fact, the science is settled, and I'm going to share with you 6 ways in which the science is settled. And I think it's true to say that every statement I make would be agreed with by most other scientists who I'm familiar with that work in this field. Not all. Science is not about complete unanimity. It's about asking questions and being skeptical. But here are 6 science facts relevant to this problem. The first is that the global temperature did in fact warm gently during the late 20th century. You've all heard about this. This is the global warming we're supposed to be so worried about. And between 1979 and 1998, the temperature warmed by about 0.4 degrees. Now, to put that in context, the background of natural climate change, there are regular rhythms on a decadal and a polydecadal timescale up to a degree of warming and cooling. So prima facie, there's absolutely nothing unusual about a 20-year-long warming phase of 0.4 degrees. But nonetheless, this is the first science fact. The facts are settled. Here it is. Global temperature warmed by about 0.4 degrees in the 20 years 1979 to 1998. The second fact is that this warming, and I've already explained it, was neither unusual in its magnitude nor in the rate at which it occurs. It's entirely indistinguishable in its physical characteristics from many previous warmings and coolings that we see in the climatic record. Did you read that in the Sydney Morning Herald this week? Do you remember that editorial they wrote saying there's no need to be alarmed about this climate change stuff, because in fact the warming we've had in the late 20th century wasn't unusual. Not only did I not read that in the Sydney Morning Herald, I haven't read it in a single Australian newspaper, and to get the SBS and the ABC to actually mention it on air would take more money and influence than I can command. Here's the third fact. Global average temperature has not increased since 1998. 1998, 12 years ago. 1998 was a particular warm year. It was the year when the warming of the late 20th century, note the warming of the late 20th century, not the 20th, 21st century. That was the year when the warming of the late 20th century terminated. And it terminated in a big spike because that happened to be the year in which one of the biggest El Nino episodes of the 20th century occurred. And El Ninos cause warming not just in the Pacific, but worldwide. But since that El Nino spike, we've now got another 12 years of accurate, modern, satellite-derived temperature results, and there has been no warming. It's gone up and down, but about an average no change. That's an interesting fact. Let me just step aside from my list of 6 and think about that. What are we supposed to be worried about? What's the hypothesis of the day that we're also worried about? And the answer is that human carbon dioxide emissions are causing dangerous global warming. Do you agree? That's the thing we get the whole time in newspapers and from the politicians. Well, okay, that's a scientific hypothesis. Now, scientists test hypotheses. That's what they do. When Joseph Banks and Captain Cook sailed into Botany Bay, and they took one of those little boats and rowed in the bay, and Banks looked over Cook's shoulder. Hey, he said, look, there's a black swan. And Captain Cook said, oh, don't be stupid. We all know that all swans are white. No, said Banks, it's a black swan. And so Captain Cook turned around and looked, and it was a black swan. But they knew, on the basis of their scientific observations, that all swans were white. How many black swans did they have to see to show that the hypothesis was wrong?
Just the one.
One, that's right. Okay, so the hypothesis is human carbon dioxide emissions will cause dangerous global warming. Between 1998 and 2010, there was no warming. Temperature was flat. Over that same period, there was a 5% increase in carbon dioxide emissions in the atmosphere. That's a test of the hypothesis, and the hypothesis fails it.